Computer Architecture and Operating System. Chapter 21. Microprogrammed Control. By Elpidio y Valdoz Jr. MSIT student, NEUST. Learning Objectives. After studying this chapter, you should be able to 1. Present an overview of the basic concepts of microprogrammed control. 2. Understand the difference between hardwired control and microprogrammed control. 3. Discuss the basic categories of sequencing techniques. 4. Present an overview of the taxonomy of microinstructions. Introduction. The term microprogram was first coined by M.V. Wilks in the early 1950s, Wilk 51. Wilks proposed an approach to control unit design that was organized and systematic and avoided the complexities of a hardwired implementation. The state of the microprogramming art was reviewed by Datamation in its February 1964 issue. IBM System/360 was announced in April, and all but the largest models were microprogrammed. Basic concepts. The control unit seems a reasonably simple device. Nevertheless, to implement a control unit as an interconnection of basic logic elements is no easy task. The design must include logic for sequencing through micro-operations, for executing micro-operations, for interpreting opcodes, and for making decisions based on ALU flags. Horizontal micro-instruction. 1. To execute this micro-instruction, turn on all the control lines indicated by a 1 bit, leave off all control lines indicated by a 0 bit. The resulting control signals will cause one or more micro-operations to be performed. 2. If the condition indicated by the condition bits is false, execute the next micro-instruction in sequence. 3. If the condition indicated by the condition bits is true, the next micro-instruction to be executed is indicated in the address field. Microprogrammed control unit. The control memory of Figure 21.2 contains a program that describes the behavior of the control unit. It follows that we could implement the control unit by simply executing that program. Figure 21.3 shows the key elements of such an implementation. The set of micro-instructions is stored in the control memory. The control address register contains the address of the next micro-instruction to be read. When a micro-instruction is read from the control memory, it is transferred to a control buffer register. The left-hand portion of that register, see Figure 21.1a, connects to the control lines emanating from the control unit. Thus, reading a micro-instruction from the control memory is the same as executing that micro-instruction. The third element shown in the figure is a sequencing unit that loads the control address register and issues a read command. Functioning of microprogrammed control unit. Figure 21.4 shows two modules labeled decoder. The upper decoder translates the opcode of the IR into a control memory address. The lower decoder is not used for horizontal micro-instructions but is used for vertical micro-instructions. Figure 21.1b. As was mentioned, in a horizontal micro-instruction every bit in the hardwired and microprogrammed control. To execute an instruction, the control unit of the CPU must generate the required control signal in the proper sequence. There are two approaches used for generating the control signals in proper sequence as hardwired control unit and microprogrammed control unit. Hardwired control. The control hardware can be viewed as a state machine that changes from one state to another in every clock cycle, depending on the contents of the instruction register, the condition codes and the external inputs. The outputs of the state machine are the control signals. The sequence of the operation carried out by this machine is determined by the wiring of the logic elements and hence named as hardwired. Fixed logic circuits that correspond directly to the Boolean expressions are used to generate the control signals. Hardwired control is faster than microprogrammed control. A controller that uses this approach can operate at high speed. RISC architecture is based on hardwired control unit. Hardwired control diagram. The control signals associated with operations are stored in special memory units inaccessible by the programmer as control words. Control signals are generated by a program are similar to machine language programs. Microprogrammed control unit is slower in speed because of the time it takes to fetch micro instructions from the control memory. Microprogrammed control unit. Important terms. Control word. A control word is a word whose individual bits represent various control signals. Microroutine. A sequence of control words corresponding to the control sequence of a machine instruction constitutes the microroutine for that instruction. Microinstruction. Individual control words in this microroutine are referred to as microinstructions. Microprogram. A sequence of microinstructions is called a microprogram, which is stored in a ROM or RAM called a control memory, CM. Control store. The microroutines for all instructions in the instruction set of a computer are stored in a special memory called the control store. Microprogrammed control unit. Diagram. Types of microprogrammed control unit. 1. Horizontal microprogrammed control unit. The control signals are represented in the decoded binary format that is 1-bit/CS. Example, if 53 control signals are present in the processor, then 53 bits are required. More than one control signal can be enabled at a time. It supports longer control word. It is used in parallel processing applications. It allows higher degree of parallelism. If degree is n, and CS are enabled at a time. It requires no additional hardware, decoders. It means it is faster than vertical microprogrammed. It is more flexible than vertical microprogrammed. 2. Vertical microprogrammed control unit. The control signals represented in the encoded binary format. For n control signals log2, n, bits are required. It supports shorter control words. It supports easy implementation of new control signals, therefore it is more flexible. It allows low degree of parallelism, i.e., degree of parallelism is either 0 or 1. Requires an additional hardware, decoders, to generate control signals. It implies it is slower than horizontal microprogrammed. It is less flexible than horizontal but more flexible than that of hardwired control unit. Sequencing techniques. Taxonomy of microinstructions. The microinstruction cycle is the basic event on a microprogrammed processor. Each cycle is made up the two parts, fetch and execute. This section deals with the execution of microinstruction. The effect of the execution of a microinstruction is to generate control signals for both the internal control to processor and the external control to processor. Taxonomy of microinstructions. Classification of microinstructions. Vertical microprogramming. Width is narrow, and control signals can be encoded into log2 and control bits. Limited ability to express parallelism. Considerable encoding of control information requires external memory word decoder to identify the exact control line being manipulated. Horizontal microprogramming. Wide memory word. High degree of parallel operations are possible. Little to no encoding of control information. Compromise technique. Divide control signals into disjoint groups. Implement each group as a separate field in the memory word. Supports reasonable levels of parallelism without too much complexity. Second compromise, nanoprogramming. Use a two-level control storage organization. Top level is a vertical format memory. Output of the top-level memory drives the address register of the bottom, nano-level, memory. Nano memory uses the horizontal formal. The produces the actual control signal outputs. The advantage to this approach is significant saving in control memory size, bits. Disadvantage is more complexity and slower operation, Doing 2 memory accesses for each micro instruction. Thanks for listening.